Okay, go ahead and check your answers. Hopefully you got r minus 1 over r plus 6, and for number 4, m plus 6 over m plus 3. Okay, let's go ahead and flip it over. You've looked at multiplying, you've looked at dividing rational expressions. The last thing we're going to look at is adding and subtracting. And in order to extend our knowledge to rational expressions, we need to start with seeing how do you add and subtract simple fractions. So, simple rational numbers. And you guys know that if we're adding 3/4 plus 5/8, we need a common denominator. So I would have to multiply this one over by 2 over 2, and that would give me 6 over 8 plus 5 over 8, 6 over 8 plus 5 over 8, which does come out to be 11 over 8. Okay, looking at the next one, I have 4 over 15, I have 7 over 11. I need to find the least common denominator between 15 and 11. And unfortunately, the only way to find the least common denominator here is to multiply them by each other. So I'm going to multiply this one by 11 over 11, and this one by 15 over 15, and that will simplify to be 44 over, and I'm going to put this in a different color just so you can see we keep the denominator when subtracting fractions, minus 105 over 165. And if I simplify that out, remember when adding and subtracting fractions, you subtract the numerators if you're subtracting, which would be negative 61, and you keep the denominator over 165. That might seem super basic to you, but looking at the rules that apply for basic rational numbers will help us to look at the rules and how they're consistent for basic rational expressions. So looking at the next example, let's take that and let's extend it. Looking at this, we know that these are factors. So if I'm looking at the factor m minus 1 and m plus 1, if I want to add these two fractions, I need a common denominator. So I would multiply this one in the same way I did that last example. I'm going to multiply this one by the second denominator, which would be m plus 1. So I multiply by m plus 1, and I multiply the second one by the first denominator, m minus 1, and I simplify. In the numerator of the first fraction, I have m plus 1 times m plus 1 over quantity m minus 1, m plus 1, and I'm going to add m minus 1 over quantity m, and I'll just change these around to match m minus 1, m plus 1. Now I can see, yes, I have the same denominator, so I'm going to go ahead, keep that denominator just like I did in the previous two examples, and I have quantity m minus 1, m plus 1, and on the numerator, I'm going to combine these numerators together, m plus 1, m plus 1, and I'm going to add that to m minus 1, m minus 1. Now, one thing that's kind of tricky here is when working with rational expressions, when adding them, you always simplify the numerator. Always simplify. So obviously I haven't done that yet. But you never multiply the denominator. Never. You keep the denominator in factored form. And the only reason we're simplifying the numerator is so that after we simplify, we could see, is there possibly still a GCF, a factor that I could divide out? So we want to keep this denominator as is, so we don't miss any GCFs. So if I simplify this out, remember you do need to FOIL the first two terms, FOIL the last two. So if I FOIL the first two, it comes out to be quantity m squared plus 2m plus 1. And if I FOIL the second two, that'll come out to be m squared minus 2m plus 1 all over, and I'm going to keep that denominator, m minus 1, quantity m plus 1. Now I add all my like terms here in the numerator, keep the denominator, so I'll write that denominator, m minus 1, m plus 1, And if I add these two terms in, or add all my like terms in the numerator, I have an m squared and an m squared, which gives me a 2m squared, a 2m and a negative 2m, which eliminate to 0, and a 1 plus a 1, which add up to be 2. Now take a look why that was so important, that step. What GCF do you now see that you could take out of the top two terms? And hopefully you're saying, well, 2, of course. So I could take out a 2, and I have 2 times quantity m squared plus 1. And in the denominator, I have it still as quantity m minus 1, m plus 1. Now that's as far as we can go, because this inside here does not match the difference of two perfect squares. But at least I've simplified and factored completely, so I can box my answer. All right, that was a long one. Let's go ahead and let's take it to the next one. Looking at the next one here, again, I need a common denominator in order to add fractions. So if I'm looking at what's the least common denominator between, and I'll start with the numbers, 3, 4, and 2, the smallest number all three of those multiply into would be 12. So I want to obtain a 12 for each of these. I'm looking at p. There's already a GCF of p in every denominator, so I don't need to worry about the p. So the first one, to obtain that 12, I'm going to multiply 3 by 4, and I need to stay consistent with the numerator. Multiply the second one by 3 over 3, and multiply the last one by 6 over 6. So I add these, or I simplify these, and I have 32 over 12p, and I'm going to keep that denominator again in a different color, plus, I see this denominator is 12p, plus 15 over 12p, plus 9 times 6, which is 54, over 12p. Add my numerators together, so I'm going to add 32 plus 15 plus 54 over 12p. And in simplifying this out, when you add these three numbers together, you get 101 over 12p. Now, if there were any common factors in 101 and 12, I would have to make sure to divide them out. But there are none, so I'm going to go ahead and box that. All right, let's flip it over. One thing to be aware of. In the previous examples, your denominators already came factored. In these examples, we just have to make sure that before we obtain a common denominator, you need to always make sure your denominator is in factored form. That will help you to see what is the least common denominator to obtain. So if I look at this x squared plus x minus 2, I'm going to factor this using trial and error. So I have the last sign is negative, so I know I'm going to have different signs. The first term, or what times what gives me x squared, which is x and x. What times what gives me 2, and I would have 1 and 2. Now I've factored this into here. And looking at the second expression, the last term's positive, so I know it's going to be the same sign, and they're both going to be negative, negative, negative. I have x times x, and looking at 4, I'm not going to use 2 and 2 this time because negative 2x and negative 2x doesn't produce a negative 5x. So instead I'm going to use the other factors, 4 and 1. Now that I've factored both of these expressions here, I can easily see what the least common denominator is. I already have a common factor of x minus 1. I have a factor of x plus 2 in this set, or in this fraction, but I need a common denominator. I need that factor off to the side here. And here, I'm going to have to pause it for a second.